Okay. Now, electrostatic potential at any point in an electric field. See, we have already seen electrostatic potential energy. Energy of a charge at any point in electric field. Now we are going to see electrostatic potential at any point in electric field. For that, let us consider a charge is there. It is plus Q, right? It has the electric field around it, and I am considering 2 points. See here, one is A, the other one is B. So I want to find out the electrostatic potential. Now, before going to put a potential difference, I want to find out the electrostatic potential difference between the points A and B. Potential difference between the points A and B. Okay. So what should I do? So I have to keep, for that, by theory, or I have to keep a unit positive charge at A. Okay. So now what I am going to do is, I am going to bring the unit positive charge from A to B. A to B without acceleration. Without acceleration. So for that, how much of work has to be done by the external force? Okay. That is the measure of what is the electrostatic potential difference between the points A and B. Okay. So as usual, the previous one we have seen, this is the field due to the electric field. That is a force due to electric field. What is that? If I keep a unit positive charge, it will experience a force, that is repulsion. But now what I want to move it in this direction. Okay, against the what is an electrostatic force. Therefore, I need to apply an external force. Okay, and such that it counterbalances Fe, so that when I am bringing the charge from A to B, there should not be any acceleration. Okay, so exactly say in the case of here, what we are bringing is unit positive charge. That's all. Okay, therefore, what is that? Here, these are all the 2 points A and B. I want the electric potential difference between 2 points, any 2 points in an electric field. Okay, yes, the amount of work done by the external force in moving a unit positive charge from one point to another without acceleration. Without acceleration. Are you following? Therefore, that is what is called electrostatic or electric. Okay, electrostatic or electric potential difference between first any 2 points in an electric field. Okay, therefore how already we have seen what is that what is the electric potential energy. Okay, electric potential energy difference between any 2 points is given by UB minus UA. For that you have to keep a unit not unit positive, a test charge, right? UB minus UA, that is nothing but WAB. WAB, correct? Therefore, this we have already seen in the previous what is that video. Therefore, UB minus UA is nothing but potential energy difference of a charge, okay, between any 2 points in an electric field, right? But what I want, potential difference. For potential difference, what you have to do, instead of bringing Q naught, okay, you are bringing unit positive charge. Unit positive charge. Therefore, what you have to do, see, you cannot, already I told you, +1 coulomb is very, very, what is that, huge. It has its own strong electric field. So that, what you have to do, you have to bring a test charge first. test charge. Therefore, when you are bringing a test charge from A to B, then it gives you, what is that? Potential energy difference of a test charge between the points A and B. But what I want is potential difference. Therefore, if I divide it by Q naught, why? Because potential difference is nothing but the amount of work done in bringing a unit positive charge. Unit positive charge. Therefore, UB minus UA divided by Q naught, that is nothing but WAB. It is the amount of work done in bringing a unit positive charge from one point to another without acceleration. Are you following? So that gives you what is the electric potential difference between any 2 points. There you are bringing a test charge. Here you are bringing a unit positive charge. Theoretically unit positive charge, practically unit positive charge is huge. So what I am doing, I am bringing first Q naught, and divided by Q naught gives you unit what done per charge, unit positive charge, and that is nothing but, okay, it is nothing but VB minus VA, potential difference between any 2 points. That is nothing but delta V. That is nothing but delta V. Are you following? Therefore, once again, I repeat the definition. Electric potential difference between any 2 points in electric field is defined as the amount of work done by the external force in moving a unit positive charge, okay, from one point to another point without acceleration. Without acceleration. Are you following? But one very important thing here is, it is not that you have to bring from unit positive charge from A to B just straight line. You can bring any like that, like it path independent. It is path independent. Okay, you have to, because initial and final point has to be same. Whatever the path, whether you are bringing it straight or any other path, okay, the value will not change. That shows the conservative nature. Gravitational field is also conservative, no? Like that, this is also conservative electric field, okay, and electric force, everything is electrostatic force, a conservative force, okay, and electric field is a conservative field, right? So this is about delta V. Now, therefore, what is the unit and dimension? Can you write? What is unit? Unit is nothing but already unit of what is the potential difference? I think already 10th standard you people have studied. Therefore, it is nothing but work done divided by Q naught, right? Work done means what is that? Joule per coulomb, okay, and that is joule per coulomb is nothing but volt. Therefore, potential difference is given in terms of what is it? It is volt. And what is the dimension? Dimension here is, what is that? Joule. What is the M? What is the dimension? M L square T power minus 2 divided by coulomb AT. Okay, therefore you will be getting M L squared A power minus 1 T power minus 3. Okay, T power minus 3. Is it clear? Okay, therefore this is about potential difference. Okay, therefore if I want to find out the potential, electric potential, hope you are following. Okay, now we will go for electric potential. Electric potential between any 2 points means what you have to do? As usual, you have to keep A outside the electric field. So electric potential, let me write here itself. Okay, so I think already we are electric potential. This is electric potential difference. What is electric potential? Electric potential at any point in electric field. Okay, for that what you have to do? You have to take A outside the electric field. Okay, therefore you will get this one as, therefore what is the UB minus UA by, what is that? Q naught. But A has to be where? A is outside the field, na? Outside the electric field, which means it is at infinity. It is at infinity. There is no need for me to once again, okay, I want to find out the electric potential at B. I want to find out the electric potential at B. Okay, now at B. Okay, so what should I do? I have to keep A somewhere here. Okay, outside the electric field, that is infinity. Okay, therefore that is nothing but that is nothing but okay, W A B infinity B by Q naught. Okay, are you following? That is nothing but UB by Q naught, because U infinity is okay, that is VB. That is VB. Therefore, you are getting electric potential at any point now by considering A outside the electric field. Therefore, how to define electric potential at any point in electric field is defined as the work done by the external force in moving a unit positive charge from infinity to that point without acceleration. Okay, electric potential at any point in electric field is defined as the work done by the external force in moving what? In moving a unit positive charge from infinity to that point without acceleration. Okay, so that gives you what is called electric potential. Therefore, if you are asked to define volt, okay, define 1 volt. Define 1 volt. You can define in terms of potential difference also, or even you can define in terms of potential also. Okay, 1 volt can be defined in terms of potential as well as potential difference. If I want to define in terms of potential difference between any 2 points is said to be 1 volt. Okay, if 1 joule of work is done by the external force in moving a unit positive charge from unit positive charge from one point to another without acceleration. Correct? Now I am giving define 1 volt in terms of electric potential difference. So what is that? The potential difference between any 2 points in electric field is said to be 1 volt when if 1 coulomb or 1 joule of work is done by the external force, okay, in moving a unit positive charge from one point to another without acceleration. Okay, right. Now I want to define the same with respect to potential. How do you say the electric potential at any point is 1 volt? Okay, so I am giving 1 volt definition with respect to potential difference and with respect to potential. Okay, now with respect to potential, the electric potential or electrostatic potential at any point is said to be 1 volt when 1 joule of work is done in moving a unit positive charge from infinity to that point without acceleration. This is the amount of work done in moving it is the potential at any point in electric field is said to be 1 volt when 1 joule of work is done by an external force in moving a unit positive charge from where? From infinity to that point without acceleration. Is it clear? So this is the SI unit. Actually SI unit, I think this you know, this is SI unit of potential or potential difference. Is it clear? Right. Now next topic is, what is that? Conservative. See, electrostatic, you have to show conservative nature. We are going to prove conservative nature of, what is that? Electric field. Electric field, you can say electric force, electrostatic field and electrostatic force. What is electric field or force? Okay, now for that consider 2 points. Okay, consider 2 points in electric field, A and B. Okay, so what I am going to do is to prove this. Okay, the conservative nature of the electrostatic force. Say I keep a unit positive charge at one point. Okay, now what is the work done in moving a unit positive charge from A to B? I am taking some path. Okay. Is given by, already we have seen WAB by Q naught, unit positive charge, na? And that is nothing but what is that? Potential difference, VB minus VA, correct? Okay, similarly what I want to do is, I'm going to bring this unit positive charge, okay, now it is unit positive charge is here now, okay. Now I want to bring it from B to A, from B to A. Let me take some other point because I told you no. So there's some other path, okay. Therefore, this path, let it be path P1, path 1, and this is path 2. Okay, therefore, now I am bringing the unit positive charge from B to A. Okay, therefore, what is the work done for that? WBA by Q naught, that is equal to VA minus VB now. VA minus VB. Okay, now what am I going to do? Add both. Why? Because therefore we get what will be the total work done. Now what I want, what is the total work done in carrying the unit positive charge, okay, over the path A to B, okay, and from B to A to B and B to A. A to B, okay, you can say, or let me say A to B, okay, and from B to A. Okay, therefore close to path. Okay, therefore now are you following? This is from A to B, path A to B. This is the work done in moving a unit positive charge from A to B. Here path B to A. What is the work done? Okay, therefore what is the work done in carrying a unit positive charge from path, okay, ABA. Okay, therefore it is the work done in moving a unit positive charge from through the path, closed path, through the closed path ABA, fully ABA, fully. Okay, therefore that is given by, what is that? You have to add 1 plus 2 na, total work done. This is the total work done in moving unit positive charge, okay, over a closed path ABA. Okay, that is nothing but WAB by Q naught plus WBA by Q naught. Following? That only gives you the total work done over the closed path. That is nothing but WABA, correct? By Q naught. WABA by Q naught. And that is nothing but VB minus VA, okay, plus VA minus VB. And what is that? That is equal to 0. That is nothing but 0. Okay, therefore it says that no work is done in moving a unit positive charge, okay, over a closed path in an electric field. Okay, in an electric field. Hence, that proves that, what is that? Electrostatic field is a conservative field, and the electrostatic force is also conservative force in nature. Okay, therefore that gives you, what is the work done here? The work done here is nothing but F dot, you can say DL or DR, whatever is the case. F dot DL now already we have seen now W. Okay, and it is from A to B and B to A for work done. Okay, this is what FDL per unit charge now divided by Q naught. Divided by Q naught and over a closed path. Over a closed FDL. Okay, DR, DL, everything, whatever you see FDL. This is work done. per unit charge, that is divided by Q naught, and that will be nothing but the work done by the, what is the external force, or it is by work done by the electric field. What is the electrostatic force? Whatever is the case, that will be minus. If it is electrostatic by external force means F dot dl, and there is F external dot dl, and if it is by the electrostatic force means then it is negative, it will be, whatever is the case. So what you will be getting here, E F by Q naught, it is Fe. If you want, it is Fe. Fe means minus. Hope you are, is it clear for you, whether it is shown clearly? See, F E. Why Fe means, what is that? Work is done, negative work now, because against. Okay. Therefore, you will be getting Fe negative dot dl. That is nothing but a negative. Go through, F external means positive, but done by the, what is that, external force. But work done by the electrostatic force means negative. No, the same thing only I am doing here. Fe by Q naught is nothing but E, na? E dot dl. E dot dl, and that is equal to 0. That is equal to 0. Therefore, line integral of electric field over a closed path. Okay, negative weight, if it is equal to 0 means that is nothing but integral of E dot dl is equal to 0, na? Therefore, line integral of the electric field over a closed path. Over a closed path, an electric field is 0. Line integral of the electric field over a closed path, that is nothing but 0. Is it clear? Okay. So this is about conservative nature of the electric field or electrostatic force. Right.